The ground beneath our feet trembles as this behemoth awakens, threatening to reshape the landscape we call home. The Lake Toba supervolcano in Indonesia has just cracked open the earth, and the consequences are nothing short of earth-shattering. What was the effect of this catastrophic event? Could this be the beginning of a global catastrophe? Are we witnessing the birth of a new era of destruction? Volcano history, stay with us till the end to find out. In the heart of the Pacific Ring of Fire, Indonesia is blessed with around 150 volcanoes that dot its enchanting islands. These majestic peaks were primarily born from the collision of the Eurasian and Indo-Australian tectonic plates, creating a geological paradise like no other. Brace yourselves as we unveil the extraordinary tales of some of Indonesia's most famous volcanoes. You might know the legendary Mount Tambora, infamous for its catastrophic eruption in 1815. The explosion was so violent that it reverberated across the globe, causing widespread devastation. Over 11,000 lives were tragically lost, making it the deadliest volcanic eruption in history. Indonesia is no stranger to volcanic activity, with 184 significant eruptions over the past 1,700 years. More than 57,200 lives were claimed by these awe-inspiring yet destructive events. The relentless power of these volcanic forces is simply mind-boggling. Today, Indonesia boasts an impressive 80 active volcanoes out of 128. And let's not forget the hidden marvels beneath the waves, 5 active submarine volcanoes lurking beneath the ocean surface. The impact of these eruptions extends far beyond the loss of life. The devastation caused by volcanic disasters ripples through infrastructure, social institutions, and the long-term economy. Just look at Mount Cinnabon, a constant source of eruptions since 2010. Hot clouds and volcanic ash have ravaged surrounding agricultural areas, leaving communities in fear and economic turmoil. The unique characteristics of Indonesian volcanoes make them a captivating subject to study. From the explosive power of stratovolcanoes to the unpredictability of eruptions, each volcano possesses its own intriguing personality. The continuous quest to unravel the secrets of Indonesia's volcanic world fuels our thirst for knowledge. However, among these fiery legends, the mighty Lake Toba volcano takes center stage. 74,000 years ago, this colossal volcano unleashed a super-eruption, triggering a 6-year volcanic winter. Imagine the world shrouded in darkness as the earth grumbled with immense power. To understand the details of this catastrophic event, it's important to delve into some fundamental scientific concepts about plate tectonics, S10, S11. Volcanoes are majestic and often terrifying natural wonders and come in all shapes and sizes. You probably made a science project of cone-shaped hills or towering mountains spewing forth rivers of molten rock known as lava. How volcanoes are formed, but have you ever wondered how they are formed in nature? The answer lies within the Earth's crust and the restless movement of tectonic plates. These tectonic plates, massive slabs of the Earth's crust and upper mantle, are in constant motion, albeit sluggishly. They slowly shift and slide, sometimes colliding with one another or moving apart. It is at these plate boundaries that volcanoes are formed. 2 types of plate boundaries are most likely to produce volcanic activity: divergent plate boundaries and convergent plate boundaries. Divergent plate boundaries witness the plates moving apart, creating a space for magma to rise from the mantle. This continuous upwelling of magma paved the way for the birth of new plate material, forming a remarkable phenomenon called a volcanic arc. Over millions of years, these volcanic arcs have shaped our world, dotting the landscape with beautiful sights. The legendary Ring of Fire, encircling the Pacific Ocean, boasts around 425 volcanoes. Imagine a mesmerizing horseshoe-shaped string of fiery views. But volcanic wonders aren't limited to land alone. The mysteries of the deep ocean reveal a hidden realm of submarine volcanic activity. Vents and fractures, known as fissures, along mid-ocean ridges, serve as gateways for magma and gases to escape into the ocean. Astonishingly, this submarine volcanic activity accounts for 75% of the annual volume of magma reaching the Earth's crust. There are vast underwater ridges stretching thousands of meters below the ocean surface, where submarine volcanoes reign. Some ridges emerge from the depths, creating awe-inspiring landforms like Iceland's mid-Atlantic ridge. These eruptions, preceded by dramatic rifts and cracks on the ground surface, are a testament to the immense power of diverging plate movement. However, let's get back to the star of today's show, the Toba supervolcano S2, S3. About 75,000 years ago, a sleeping giant awakened. The Toba supervolcano in Indonesia unleashed its fury, releasing an astonishing 100 times more sulfur dioxide, into the stratosphere than the infamous Mount Pinatubo eruption. This unleashed a global chain of events that forever altered the course of Earth's climate and our very existence. The impact was colossal. Climate model simulations estimate a bone-chilling global cooling of 3.5 to 9 degrees Celsius, casting the world into a volcanic winter of unprecedented proportions. But that's not all. Precipitation plummeted by up to 25%, triggering devastating droughts and wreaking havoc on ecosystems and humanity. The Toba super-eruption didn't stop at freezing temperatures and parched lands. It had another trick up its sleeve. Through the power of Earth system model simulations, scientists have uncovered a hidden danger that few could have anticipated: severe stratospheric ozone loss. The plume of volcanic gases from Toba created a radiation attenuation mechanism that wreaked havoc on the ozone layer, particularly in the tropics. Over a year, depleted ozone conditions persisted, casting a shadow of uncertainty over the future. How volcanoes impact our world, but how does this ancient catastrophe relate to us today? The answer lies in the eerie parallels between past and present volcanic eruptions. The infamous Mount Pinatubo eruption of 1991 may have released significantly less sulfur dioxide, but it left an indelible mark on our world. A global cooling of 0.7 degrees Celsius, prolonged El Niño effects, and the unforgettable year without a summer illustrate the profound environmental impacts that volcanic eruptions can have on our planet. Back to Toba, recent advancements in geochronology have shed new light on the true magnitude of the super-eruption. Scientists have uncovered a startling revelation by analyzing helium in samples from smaller eruptions. These smaller eruptions, believed to be the same age as the super-eruption, were younger by up to 13,000 years. This breakthrough has revolutionized our understanding of volcanic timeframes, showcasing the power of cutting-edge techniques and unraveling past mysteries. Imagine a world blanketed in ash, stretching for 100 kilometers in every direction around Toba. The ash spread far and wide, reaching the oceans and creating colossal plumes that painted the sky in a dark veil. The impact was felt regionally, leaving no corner untouched by this ancient cataclysm. What was the effect of this massive eruption? S4, S5, S6. This volcanic eruption was so immense that its effects rippled across continents, reaching as far as southern Africa. This wasn't just any eruption. It was the most powerful eruption witnessed on Earth in the last 2 million years. The magnitude of this event was staggering, pushing our early human ancestors to the brink of extinction when they were just beginning to explore beyond Africa's borders. Gene Smith, a renowned geologist at the University of Nevada, Las Vegas, describes Toba as a force of nature. Its impact on the environment and human evolution is a tale of survival against all odds. While some scientists believe that the Toba eruption spelled doom for our ancestors, artifacts tell a different story. Humans not only survived but thrived in the aftermath of this volcanic catastrophe. The resilience and ingenuity of our early forebears shine through the artifact they left behind, a testament to their ability to adapt and overcome adversity. The connection between the Toba super-eruption and human genetic variability has puzzled researchers for years. In 1998, anthropologist Stanley Ambrose first linked the low genetic diversity in modern humans to the Toba eruption. Genetic evidence suggests a significant population collapse around 74,000 years ago, with only a few thousand survivors who became the ancestors of all present-day humans. According to the Toba catastrophe theory, most early humans outside Africa perished as the climate and environment rapidly changed. However, archaeological and paleoclimate records have presented a contradictory narrative, leaving scientists needing clarification. Intriguingly, a breakthrough in climate modeling has shed new light on this enigma. Benjamin Black from Rutgers University and his team employed cutting-edge techniques, analyzing 42 global climate model simulations. Their findings challenge traditional assumptions and reveal a crucial piece of the puzzle. The climate response to the Toba eruption was not uniform across the globe. While Africa and India experienced relative shelter from the eruption's impact, North America, Europe, and Asia bore the brunt of the cooling. But how did this massive eruption shape ecosystems and humanity? The Toba plume profoundly affected the ozone layer, inhibiting oxygen photolysis and causing severe ozone depletion in the tropics. This, combined with a volcanic winter experience in other regions, helps explain the far-reaching impacts of super-eruptions on ecosystems and human survival. Is there a possibility of a Toba super-eruption again? S12, S13. Experts estimate that Toba's magma reservoir currently holds around 320 cubic kilometers of molten rock, a fraction of what was expelled during the super-eruption. While not classified as a super-eruption, this still possesses enough power to cause global disturbances. Adding to the mystery, researchers suggest that approximately 4 cubic kilometers of magma accumulates in Toba every 1,000 years. This indicates that the next super-eruption, of lesser magnitude, could occur in approximately 600,000 years, while smaller eruptions might transpire in the interim. The challenge lies in the uncertainty of when the next flood lava event will occur. While experts anticipate another occurrence within the next 50 million years, the exact location and timing remain elusive. If you liked this video, don't forget to subscribe to Deep Astronomy and like and share it. Want more? Simply click the next video on your screen. Thanks for watching.